All right, so it says consider the differential equation dy dx equals negative 2x over y. On the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. Sketch your slope field. I'm not doing it for you. The slope field, like it says. Okay. Slope fields, dy dx is our slope, right? So we're not separating anything. We're using this. Yeah, what happens when x equals 0? It's 0. So all the ones for x equals 0, we have 0 slope. Well, not all of them, not at 0, 0, because then it's undefined, right? When x is 1 and y is 1, then that's a negative 2. When x is 1 and y is 2, you get a negative 1, right? And those have to look distinctly different. When x is negative 1 and y is 1, we get a positive 2. When x is negative 1, y is positive 2, we get a positive 1, right? And negative 1 will give us a negative 2. I've got that backwards, hang on. I did those backwards. Oh my gosh, why can't I erase? I want this erase. This board drives me insane. I don't know. Well, I can't erase that. I don't know why. Well, but even when I've done that, sometimes, maybe. Nope. See, it's not. I don't know. All right, so let me just start. So we're going to just ignore that. Maybe I'll do these in a different color. Because that one's wrong, and I don't know why it won't go away. All right, so starting back over. This would be a negative 2, which makes it steeper. Negative 1 is not as steep. I think I had those backwards. Negative 1, 1 is going to give me a positive 2, and this would be a positive 1. So then this is going to be a negative 2, which is probably more like that, and then a negative 1, which isn't as steep. Looks something like that. Okay. We good? Okay. All right, so now it says, let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. We're going to write an equation for the line tangent to the graph of f at 1, negative 1, and use it to approximate. See, this is going to stay there. This happened to me the other day. I don't know why, but it's not going away. Well, just see. It's what? I know. I agree. Yeah, well, they're new, but they're old. I think they were developed like in 2016 or something. Like, they're not the newest of the new technology. That's just the way we roll around here. So, all right, so On B, let y equals f of x be the particular solution to the differential equation with the initial condition f of 1 equals -1. We're going to write an equation for the line tangent to the graph of f at 1, -1, and use it to approximate f of 1.1. So what do I need to do first? Get them on each side, okay, of this up here. Solve for y. What is it asking us to do? Yes, write an equation for the line tangent to the graph. So the first thing we do is we write point and slope, and then we figure out how we're going to find those things. Okay. So do I know the point? Yes, it's 1, -1. They gave me that, right? How do I find the slope? We have the dy dx, exactly. So if I take that dy dx and I evaluate it at this point, that's going to be a negative, and let's see, it was 2x. So 2 times 1 over -1. What does that become? 2. That's my slope. Okay, that makes sense? All right, so I'm supposed to write the equation of the tangent line. I can do that at this point. So this is going to be y equals the slope, which is 2, times x minus 1 minus 1. Do we agree with that? Okay, so then it told us to write that. Boom, we wrote it. Then we're supposed to use it to approximate f of 1.1. So what do we do now? We just plug it in. So we can say that f of 1.1 is about 2 times 1.1 minus 1 minus 1. 1.1 minus 1 is 0.1. Does that matter? Do we care? No. Do I have an approximation for f of 1.1? Yes. Do I stop? Yes. I stop. I'm done with this. Okay? Now, here's why we don't separate and solve, even though it's telling us, it's talking about a particular solution, it's talking about a differential equation. It's because this says let y equals f of x, where this says find the particular solution. When you're told to find it, that's when you separate and solve. You with me? Okay, so that's why we didn't need to do that. Yes, we used it to find our slope, but we didn't have to do anything with it. Now we need to, so I'm going to rewrite it. So I'm going to write dy dx equals negative 2x over y, since I can't see it up there. So what do I do next here? Move the dx, so I'm going to get dy equals negative 2x over y times dx. Then I can multiply by y, so y equals, not y equals, y times dy equals negative 2x dx. Do I substitute in this 1, -1 here? No. What do I have to do before that? Integrate. I have to integrate this, right? This is the derivative. I'm going to integrate it so that it will give me, when I integrate y, that's going to give me y squared over 2 equals negative 2x squared over 2 plus c, which is really just negative x squared. But I think I lost somebody at some point yesterday and didn't mean to do that. Okay, and then this is, kind of looks like I was trying to draw a funky face with a little winky eye, but I think it's from my sweatshirt. Not really sure why that's there, but okay. I have to learn to stay farther away from the board. Okay, so I've got two options here. I could solve for y, but I also could just go ahead and solve for c. The more efficient way most of the time is just to go ahead and solve for c. Okay, so we're going to substitute that in. We have f of 1 equals -1, so what do I substitute in for y? -1. -1 squared over 2 equals, so this is, these 2's cancel out here, right? So I really just have -1 squared plus c. All right. What was I going to say? So this is going to give me 1/2 equals 1, negative 1, plus c. Is it 3/2 equals c? Y'all agree with that? Okay. Now, what do I do now? Put the c in there and rewrite it. Yes, so I'm going to put c in here. And now I'm going to solve for y. So I'm going to have y squared over 2 equals negative x squared plus 3/2. Well, the 2's canceled out, so I just left them out. Does that make sense? I mean, it's fine to put them in there, but they'll end up canceling back out. All right, so now I got to get rid of this 2. So I'm going to multiply both sides by 2. This whole thing gets multiplied by 2, and this gets multiplied by 2. When you do something like this, make sure you distribute like you're supposed to. Those cancel out, so we get y squared equals negative 2x squared plus 3. Then what do? Square root. So y equals plus or minus the square root of negative 2x squared plus 3. Then I need to decide, is it plus or is it minus, because it's not both. So the y value that we have for this particular solution, is the y value positive or negative? It's negative. Since this is negative, that's why this would be y equals negative square root of negative 2x squared plus 3. And that's your answer. What questions do you have? We good? All right. Let's look at this next one. Little pink, it says find. Exactly. Good catch there. So it says find. So since it says find, the first thing we're going to do here is separate, right? So dy equals 3x squared over e to the 2y times dx. Everybody with me? Then we multiply both sides by the denominator, so I get e to the 2y dy equals 3x squared dx. Then what would I do next? Integrate. I'm going to integrate both sides. So this e to the 2y, when I integrate it, well, what should I do here? It stays e to the 2y. We could do e to the 2 times or plus e to the y. That works. Or, I'm sorry, times e to the y. But then I have a product, and I don't know that I want a product. Should I maybe use some u substitution here? Say u equals 2y. So du equals 2 dy. Right? So that means I got to multiply this by 2 and this by 1/2. And then I can treat that as a u, even if I don't want to rewrite it. So that means I'm going to have, well, I can rewrite it. 1/2 times the integral of e to the u du equals, do I need to do any u stuff on the right? No. And so this is just going to be x cubed. Would you agree with that? Because I'm going to add 1 and then divide by 3, and then I can put my plus c. Then when I actually integrate over here, it is going to remain e to the u, so I'm going to have 1/2 e, and since it's just going to be e to the u, I can go ahead and put the 2y back in, because that is my u. That equals x cubed plus c. Okay. Everybody with me? So, and then you have two options here. Like we could go ahead and substitute in now. We don't have to solve for y the whole way, but we could go ahead and make this, like, get rid of that 1/2 and multiply both sides by 2. It doesn't matter either way, and I want you to know it doesn't matter either way, because whether we do it now or we wait and use it as is to find c, that means we'll get two different c's, and that's okay, because then when we substitute it back in and actually solve for y, we should all end up with the same answer in the end. You with me on that? So do you want to leave it, or do you want to go ahead and multiply both sides by 2? Let's multiply, but we can get rid of the fraction, right? So when we do that, we get e to the 2y equals 2x cubed plus c, not plus 2c, right? Plus c, because c is still a constant, and it can be different depending on when we solve for it, okay? We good? So this would be a good time for us to go ahead and use our initial condition here. So when I do that, that's going to give me e to the 2 times 1/2. Oh my gosh, my sweatshirt is making a little weird things. Equals 2 times 0 cubed plus c, right? What's 2 times 1/2? 1. And e to the 1 is just e. Okay, what is happening here? Oh my goodness, I think I just shut out and I don't know why. Either that or it popped up over here. Oh my goodness. No idea why this just shut down, so give me a second. Okay, so okay. So some got to rewrite some of this, but deep breaths. What? I think, man, just getting my old board back. This is equal. Oh no. Well, Miss Bruce warned me. She said, you're not going to want this. Not why I said, no, I didn't want it. 2 times 0 to the 3rd plus c. Okay, so e to the 1 first is just e. That's equal to c. Yeah, I know. They look like little arms or something. I don't know. So c is equal to e. We good with that? Okay. So now we take this, and we're going to put it back into here. What? What were y'all arguing about?
You said e equals c. I said no. C equals e.
Oh. Yeah. I usually do write c because it was drilled back in the day. Your variables were on the left no matter what. That's kind of how it was drilled into my brain. All right. So I have e to the 2y is equal to 2x cubed plus e. We good with that? Now, how do I get the 2y out of the exponent with e? No, sorry. Natural log. Logs undo exponentials, right? So at this point, and let's rewrite this step just so I'm going to take the natural log of e to the 2y. That's equal to the natural log of 2x cubed plus e. You with me on that? Yes. That's why I'm having you write this step. Okay. So when we do this, we're going to write a couple extra steps because we don't know what we're doing with logs, all right? We have an exponential rule that says this 2y can come out into the front. So 2y times the natural log of e equals the natural log of 2x cubed plus e. Everybody with me on that? All right, so log, what's the base of a natural log? E. So it's 1, because when the base and the argument match, this just becomes 1. So basically this is just 2y on the left. Okay, well, let's just rewrite that to be. So we get 2y is equal to the natural log of 2x squared plus e. And then just divide by 2. That's a very good question. Sorry, it's 2x cubed. Y equals, so we can do either all of this over 2. How did y'all write it? Did you write it all over 2 or did you put 1/2 in the front? Okay, either way is fine. So natural log of 2x cubed plus e. Oh, that's a 6. Oh my gosh, I really am. Plus e all over 2. Okay? And make sure that you understand that this is the same thing as y equals 1/2 times the natural log of 2x cubed plus e. One is not better than the other, but for multiple choice purposes, make sure you recognize that those are the same. Okay? We good? So again, now we really don't deal with common logs, like just the log log. Really, natural log is going to be the one that you see the most. So we are getting a variable out of the exponent. You take the natural log. So you could skip these steps. The natural log of e is 1, so you could go from here straight to here, and that would be fine. Okay, does that make sense? All right, we good? What questions do you have? All right, grab that other blue piece of paper that I gave you. Oh, shoots. And give me a second because I don't think I have it up there. It's in a separate file and I didn't put it in there. Here we go. Okay. All right, so the second piece of paper I gave you, we got it? Why are y'all waiting to get it out now? I said that before I walked back there. Okay, we're going to do, well, some of y'all actually did what I asked you to do and started this, right? Okay, that's okay. I didn't say you had to do it at home. I just said I'd like for you to try it beforehand. Okay, and you finished the second one, good. And I kind of told you to stop on this one just because I didn't want you making up math. All right, so we've got this. So it says find. So that's how we know we're supposed to separate and solve. So when we do that, we'll start by multiplying dx. So dy is equal to x squared times y minus 1 times dx. So this means I will get 1 over y minus 1 times dy equals x squared dx. Okay. Now you could have put dy over y minus 1, but I wanted to make sure that you could see this was a 1 over a variable situation, right? At this point, we need to integrate. Right. So when I integrate on the left, what do I need to, how am I going to handle this? Okay, so you want to at least, it is going to end up being a natural log. A u substitution is definitely might be a need here, because technically it is a need here. But when you do that, so we got u equals y minus 1, right? So du equals dy. So we're good on that. So we can just think of this as 1 over u. And then we don't have, because the derivative was just plain old dy, we're fine. We don't really have to do, like, substitute it in. So this just becomes the natural log of the absolute value of y minus 1. That make sense? So yes, you want to think through that, because if that was 2y minus 1, then it changes the game, and you have to use the u substitution part of that, okay? And then this would equal to x cubed over 3 plus c. Okay. Now, this is the step where we have been substituting in the initial condition, right? As per advice from Miss Bruce, you could always solve for y before you substitute it in every single time. Sometimes it's more efficient, like on the last ones that we did, not to do that. On this one, if you have a natural log situation, then it is a little bit more efficient for you to actually solve for y before we do anything else, okay? It makes it a little bit easier. So the only time you really it's your preference one way or the other on all of them, but as far as what's more efficient, what might save you some work, what might make a little bit more sense, is at this step substituted in most of the time unless you have a natural log. Does that make sense? Okay. What? Why would you have a natural log of 2? Okay, yes, but then once it's not a matter of C being difficult to find. It's being that this is going to be more complicated to handle when you find C right now. Does that make sense? Because it's not difficult to find C at this step. You're right. Okay. So we're going to solve for y, which means I got to get y out of the natural log. How do you think we can do that? I heard multiply by e, and I heard what? Exponential. Okay. So we're not really multiplying by e, but I think you're on the right track. It's more of an exponential thing. We can't divide by the natural log because the natural log is an operation. So it's like trying to divide by a square root sign. Does that make sense? Okay. Good thought, though. We're thinking. So just like we had to get a variable out of the exponent of e, we took the natural log. We need to get this out of the natural log, so we're going to use e. This is why we did last year in pre-cal, and you did in Algebra 2, rewriting logs as exponentials. What's the base of a natural log? E. So we take the base of the natural log to, okay, I am going to draw something, let me do it in a different color. You take the base of the natural log, which is e, to this power, and this is what it equals. The 10 is the base of the common log. So like when you use LOG, then and there's no base there, it's 10. So this, when you don't see the base, it's e, okay? So we're going to do e, this is the base, to the x cubed over 3 plus c power equals y minus 1. All right, and so here's why, because I was kind of told to just kind of ignore this and move on, and y'all might not catch it, but this is where this discussion has come up, because technically this is still the absolute value, right? And when you solve an absolute value, you have a plus or minus answer. You end up with 2 answers, then you got to figure out which one is right. The reason we get to drop these is because you can only take the log of a positive number anyway, so we only want the positive version of what comes out of here. Does that make sense to you? So then we get to drop it, and we don't care about the negative version of this. It doesn't even matter. Okay? So then when I go to solve for y, I'm going to add 1 to both sides. So I get y equals e to the x cubed over 3 power plus c, all that's in the numerator, and then plus 1. Okay? How do we even solve for c? We're not going to worry about it until we've substituted something in. You're worrying a few steps ahead. Okay? And sometimes when we worry a few steps ahead, we freeze. We don't want to freeze, right? Because we can do the next step, yes? All right, let's do the next step. Substitute. Okay, so y is 3. That's equal to e to the 0 over 3 plus c power, right? Plus 1. So 3 equals e to the c plus 1. Then I subtract. So 2, shoot some letters. 2 equals e to the c. How do I get e out of that? Or, I'm sorry, how do I get c out of that natural log? So when I take the natural log of both sides, I'm going to have the natural log of 2 equals c. Because remember, the natural log of e is 1, and that c gets to come out front. So do you also see, because I know, Cameron, from the beginning you said, isn't c the natural log of 2? Here, technically, it'd be the absolute value of 2, which is still just 2, I guess. But we also wouldn't have to then try and solve for y in here with that natural log hanging out over here. Now that we have this, I can put it all back into here, right? This goes into here. So I get y equals e to the x cubed over 3 plus the natural log of 2 plus 1. Which looks all crazy weird. I know. We're going to back up to, because I was like, something is not right here. What did I do wrong? Okay. E to the C is a constant, so e to the c is just a constant. It's not the subset, because I was thinking, I ended up with the same thing that Cameron did. Okay. Oh, goodness. Well, I mean, when you said the natural log of 2, I was like, that's not really supposed to be in the answer. No, it's not his fault at all. But when we get here, this is what we have to do. Whew. Okay. Hang on, now I'm sweating. We want c out of the exponent before we even get there, all right? I'm going to have to figure out why what we did, I'm going to go back and look at that, because it really shouldn't matter how you solve for c. I'm going to have to rethink this a little bit. Oh, it ends up being the same. Oh, it ends up being the same thing. Hang on. No, it's okay. It's okay. I'm going to put this back. No, I'm not, because it won't let me. Oh, thank you. Okay, I'm going to leave this. I'm going to leave this, and then we're going to come, but we're going to do it differently, but I want to show you why it's the same thing, okay? What is it supposed to be? This, then plus 1. Okay. All right, we're good? We're going to start back here. I'm going to rewrite that. Okay, so y'all help me out, because I don't even know what it was. Thank you. Plus c, plus 1, plus 1, okay. And it is the same thing, because I was like, it has to still be the same thing, and it is, and I will show you why in just a minute. But it would just be the more complicated way to do it. Golly geez. Okay, glad I caught myself here. We did something like this when we separated because I had to go look, I worked it out 2 different ways, and my other way was over there. And it was, well, we're going to split the e. So look, y equals e to the x cubed over 3. Remember your rule when we add exponents? That's times e to the c plus 1. Right? Everybody with me? Okay, so c is a constant. Therefore, e to the c is a constant. Yes. Okay. E to the c is a constant. Everybody good with that? So this really, itself, being a constant, is just c. So the way we write this is y equals c times e to the x cubed over 3 plus 1. Let that soak in for a minute, because I know that's a little weird. Does that make sense to you? It will, I promise. Are we all good? Everybody with me? All right, I don't know, why don't I even have this written up here? I don't know what I did with my version of this. It must still be over there. Okay, so then y'all are going to have to remind me. I don't know what x and y are. What was y? What's y? 3? Okay, that's equal to c times e, and x was 0? Okay, so it's 0 over 3 plus 1, right? Okay, so e to the 0 power is just what? Well, this is 0. E to the 0, all of this is just 1, if we're trying to get at. So 3 equals c plus 1. So c is actually equal to 2. Which means, and I'm going to show you why we would still get there from what we have and why it's the same. I'll show you in just a second. So we have y equals, where are we? Oh, we're here. We have this one. Y equals 2e to the x cubed over 3 plus 1. That's our actual final answer. Now, you don't have to write this down, but I want to show you why we weren't technically wrong, just not finished. But because it's on the other page, you're going to have to tell me what it was. It was y equals e to the x cubed over 3 plus the natural log of 2. Is that right? Yes. Plus 1, which looks a whole lot worse than that, doesn't it? Okay, And again, you don't have to follow, you're not going to have to do this. Just let me show you why it's the same. This is the same thing as y equals e to the x cubed over 3 times e to the natural log of 2 plus 1. You see how I just split it like we did over there? Okay, e to the natural log of 2, because these are inverses, that is just 2. So it's y equals 2 times e to the x cubed over 3 plus 1. But that right there is why you want to solve for y first. Okay? Remember, you don't have to write this down. You don't have to do this. But if you solve for y and actually go all the way, I stopped too soon. That was my problem. And then I just made it I made it way more complicated. And I apologize for that. So because I messed up, I think we lost the whole point of why we were even doing that. Yeah, I know. I worked it out 2 different ways, and I think my other way is back. I don't know. Both of my ways are back there. I didn't bring my paper up here. That's part of my problem. All right. Are we good, or are we just totally confused now? Halfway confused? All right. We're going to do another one where I don't mess you up on Monday, just so that, or Tuesday, or whatever we come back, Wednesday? I don't know. All right. Where is the... Oh, that's still not the right one. I didn't say we were done. It's not. All right, let's look at this one. We are not done. Is your second? You might be done, but we're not done. Okay. All right. So we're finding the particular solution. So dy is equal to y squared times 6 minus 2x dx. Then I divide, right? dy 1 times y squared. Or you can do dy over y squared equals 6 minus 2x dx. Then what do I have to do? Integrate. So go ahead and integrate. No. No, thank you. Yeah, there's just some different examples. So some application stuff. And there's a practice set number 2. It's okay. Just what I want you to do on the green one is I want you to. We are not done with the blue one, Cameron. Yeah. The green one, I want you to see what all you can do, because we're going to do these on Wednesday, but then we're done with this unit already and kind of ready for a test. So if you don't actually practice some of this on your own and know what you can and can't do, you might be completely lost and be sad. Okay? Mm-hmm. Probably Friday. Not yet. No, probably going to end up taking them home with me. Would it be helpful to rewrite this as y to the negative 2 power? Yes, it would. Okay, so that means that I add 1. So that means I get y to the negative 1 divided by negative 1 equals 6x minus x squared plus c. Would you agree with that? Those of you that did it, you agree with me? Good, thank you for doing it. Negative 1 over y equals, that's an equal sign, 6x minus x squared plus c. So since this does not have a natural log in it, then I would say let's go ahead and substitute now. Okay? That's no, I know. I'm like, I'm not even erasing these anymore. So my y value, this is going to give me negative 1 over 1/4 equals 6 times 3 minus 3 squared plus c. It's just negative 4, right? We shouldn't have to stress out over something like that. That's equal to 18 minus 9 plus c. So negative 4 equals 9 plus c, right? So C equals what? Negative 13. So when I substitute it back in here, I get negative 1 over y equals 6x minus x squared minus 13. What's the easiest way to get y? Yeah, so if I multiply by, basically if you have a fraction equal to something that's not, you can just switch this with the denominator and it's the same thing. It is multiplying by y and dividing by that, but you don't necessarily have to write those steps every time. So that'll still give me negative 1 over 6x minus x squared minus 13, and that's equal to y. Okay, that's fine.
But then I also put like 1 over y equals.
Oh, that's totally fine. That is totally fine. So whether you have this, or if you have, and this is good to know for multiple choice, if you have negative 6x plus x squared plus 13, yeah, that is totally fine. They're the same thing.
It's because I put x squared in the front.
Yeah,
And then I stacked it up.
totally fine. Yes, yes. Yes, so the question is, instead of going on the numerator, can it just come out here? Yes, but here's what you can't do. This is important. Y'all, everybody look up here. Here's what you can't do. You see this negative right here? I cannot do negative. I can't pull that negative out and make this 6x plus x squared plus 13 equals y. That is not true. So be careful when you pull them out front like that you're doing it legally, okay? All right, so y'all try. Actually work on these before I see you again on Wednesday. Try to read through the word problems. Use some reasoning in your brains. Sit, Lolly, I'm sorry that this video was such a hot mess.